Of the 46 slides in our historic collection, 30 of them have galaxies on them, and yet none of them are properly labelled as them. So, why did we call them nebulae until around 100 years ago? And why didn't we properly understand the scale of the universe? See yonder, lo the galaxy, which men cleppeth the Milky Way, for hit is weight. These the words of Geoffrey Chaucer, back in the 14th century, and the first written example of the word galaxy being used. At this point, the word galaxy was used specifically for the Milky Way, with the root for the word coming from the Greek gala, meaning milk. Then we had no idea of the structure of the Milky Way, or anything that existed beyond it. To be fair to astronomers of this era, they had no telescopes, no photographic means of recording their observations, and no way of determining the distance to stars other than the Sun with any sort of degree of accuracy. At this stage in human history, most people believed that the Earth was at the centre of the universe and that all other objects orbited around us. This is obviously not what we understand as fact today. Just look at how the other planets have these weird epicycles in their orbits just to make things work. If we wanted to know about the positions and details of the sky, astronomers of this era had to observe closely and then manually draw out what they saw. So the quality of the understanding would depend not only just on the observations, but the artistic ability of the astronomers to accurately depict objects that they could not see magnified. Not until the 1600s, at least. Before telescopes, other galaxies were either too faint to be seen with the naked eye or too small to see any details on. Andromeda, the nearest major galaxy to the Milky Way, is visible to the naked eye and so had been seen by astronomers long before the invention of telescopes. In the 900s, Persian astronomer Abd al-Rahman al-Sufi described it as a small cloud or nebulous smear. It wasn't until astronomers started using telescopes that greater details could be determined. In the 1600s, German astronomer Simon Marius, when he wasn't arguing with Galileo about who observed moons about Jupiter first, looked more closely at Andromeda. He described it as looking like the flame of a candle seen through a horn. From here, further astronomers started to add their own thoughts over the centuries, following on from Messier, adding it to his catalogue of star clusters and nebulae. We started to get an idea of the structure and distance to Andromeda, with 3 Williams leading the way. Herschel attempted to estimate the distance to Andromeda, putting it at about 18,000 light years away, which, to be fair, was only a factor of 140 out, which, not bad for the era. Parsons observed the spiral structure of Andromeda, and Huggins looked at the spectra of colours from Andromeda, realising that it matched better to the spectrum of stars, which allowed us to realise what it was actually made up of. But through all of this, it was still referred to as the Andromeda Nebula, not a galaxy in its own right. For a long time, we didn't. If we go back to the geocentric model of the universe from earlier, whilst the objects of the solar system orbit about the Earth relatively nearby, other stars are positioned further out as more of a fixed boundary for the edge of the universe. Many astronomers had the Milky Way at the same distance as these stars, with Aristotle stating that it was formed from fiery exhalations of the stars that were in close proximity to one another way back in the 4th century BCE. By the 11th century, the forefront of astronomical advances were coming from the Middle East, with Al-Biruni suggesting that the Milky Way consisted of stars, and Al-Hazan determining that the Milky Way was much further away than many of the other stars that we could see in the night sky. In the 1600s, Galileo managed to confirm that the Milky Way was made up of stars, with the use of recently developed telescopes helping to see greater detail versus the naked eye on its own. Telescopes have obviously improved in quality since these early days, with greater detail and depth visible to later astronomers. It wasn't until the 1700s that we had any decent suggestion of objects existing beyond the Milky Way. Thomas Wright published his book, An Original Theory or New Hypothesis of the Universe, in 1750, with the suggestion that what had been named as nebulae were not actually part of the Milky Way. If you have a chance, by the way, have a proper look at the illustrations from this book. The visualization of separate groupings of stars is absolutely fantastic. Only 5 years later, Immanuel Kant would conclude that the Milky Way was a rotating disk of stars and that these nebulae were their own galaxies. This is the first record that I have found of other objects having the name galaxy associated with them, though I do prefer Kant's alternative name for them, which was island universes. In the early 20th century, there were a number of significant advances in our understanding of astronomy, which I'll give a very brief rundown of here. In fact, this era was a really important one for a number of areas in physics, with advancements across the board. Henrietta Swan Leavitt was working for Harvard University as a human computer, studying Cepheid variable stars, which are a particular type of star with a variable brightness. This occurs due to their size actually expanding and shrinking, which happens on a regular cycle. Leavitt noticed a direct proportionality between the mean luminosity of these stars and their time period of their cycles, having identified nearly 2,000 such stars during her career. This discovery allowed this particular type of star to be used as something called a standard candle. This meant that if you measured the apparent brightness of these objects from Earth and used their time period to work out their mean luminosity, then you could calculate the distances to much more distant objects than with previous methods such as heliocentric parallax. Without Leavitt's work, astronomers would not have been able to work out the distances to nearby galaxies and realise how far away they were. She arguably deserved a Nobel Prize for her work, in an era where her most important academic paper was signed off and communicated by the director of the Harvard Observatory, Edward Pickering, with a note that the paper was prepared by Miss Leavitt, though sadly she died in 1921 before anyone could actually nominate her. In the backdrop to this, parts of the astronomical community were getting more behind the idea of separate galaxies, though others were more entrenched in their views that nebulae existed only within the Milky Way. Two of the leading lights on this, Shapley and Curtis, went head-to-head on the matter in 1920 in what was known as the Great Debate. I'm not going to go into specifics here, but do look it up after you finish this video, of course, to see what evidence each side presented, if you want a bit of a deeper look on the topic. In the years that followed, observations of Cepheid variables in Andromeda and other galaxies showed that they were indeed much more distant than just clouds of dust and gas at the edges of our own Milky Way. Leading the way on this was a man called Hubble, I think you might have heard of him, though observations by others, including Opic, helped to pave the way further. In time, these objects, previously known as nebulae, would be recognised as galaxies in their own right. It might have been too late for the labelling of these slides, but this work led to a complete revolution in our understanding of the structure of the universe, with Hubble's observations going on to support the idea of an expanding universe and the Big Bang that started it all. That, though, is a story for another time. For today, I hope we've shown just how complex progress can be within the sciences, and that the knowledge we take for granted today is the product of thousands of years of progress. Next week, we're going to be addressing a mistake from one of the earlier videos in the summer slide series and trying to learn about the origin of the slides themselves in the process. In the meantime, thanks for watching today's video. Give us a like if you've enjoyed it. Let me know what bits of history I've skimmed over in the comments, and please do subscribe to help the channel to continue its growth. Until next time, please continue to watch this space. Thank you.